Hello! Today I'm going to show you how to solve a set of simultaneous equations where one or both of the equations are nonlinear, so it doesn't involve a straight line. We'll start off and we'll look at a set where it's linear and quadratic. So the linear equation, we're going to have y equals x plus 3. And for the quadratic, we have y equals x squared plus 5x minus 2. So the method's going to involve, again, trying to eliminate one of the variables, one of the unknowns. So here we can see we have two equations, both with two unknowns in them, and we want to end up in a scenario where we have one equation with one unknown. So this can be done quite simply in this case, because we have y is equal to something and y is equal to something else, both where y isn't involved on the other side of the equation. So we can set these two things equal to each other effectively. So we can have x plus 3 is equal to x squared plus 5x minus 2. And now we can rearrange this and try and solve this. This will give us the values for x, and then we'll plug them back into either equation, but generally the linear one is easier to plug it back into, to find the y values. So rearranging this then, we have x squared plus, well, 5x minus x is 4x, minus 2 minus 3 gives us minus 5, and then there's still 0 on the other side. Factorising this then, we get x minus 5, or x plus 5, and x minus 1 as well, equal to 0. So we have x is equal to 1 and minus 5. Very nice. So now we'll take these two values and we'll plug them both into the linear equation and see what values we get. So y, evaluated at x is equal to 1, is going to be 4 for 1 plus 3. And doing the same thing for the minus 5, y, when x is equal to minus 5, it's going to be minus 5 plus 3, so that's minus 2. So the solutions to our set of simultaneous equations is going to be 1, 4, and then also minus 5, minus 2. Beautiful. We can always verify this just by taking like the value for x, plugging it in here, and hoping we get 4 out. And same one for tip minus 5, plug it into here, and hopefully we get 2 on the other side. If that happens on both equations, then it's definitely a correct solution. So we'll have a look at a situation then where one isn't a quadratic, but it's a circle instead, and see if that's any different. So this was linear, quadratic. We'll have a look at a linear and a circle. So the circle will have x squared plus y squared is equal to 13. And for the linear equation, we have x is equal to y minus 5. Notice this isn't given in the form y equals mx plus c. That's completely fine. Doesn't matter which form it's given into. Doesn't even matter if it's explicitly stated. It could be written as like x divided by y, something like that. For example, if you rewrote this, if we divide it all sides by x, we'd have is equal to y over x minus 5 over x, which looks a bit weird, but it's still a linear equation. As long as you rearrange everything in the right manner, it should be fine. So here we've got x equals 2, and we're going to basically substitute this value in place of x. So the x squared is going to become y minus 5 squared, and then plus y squared is equal to 13. So now we're at a situation where we have one equation with one unknown in it. We can rearrange this and try and solve it. So let's expand our bracket. We'll have y minus 10y, y squared minus 10y plus 25 plus the y squared is equal to 13. Collecting all the like terms, we get 2y squared minus 10y, and then 25 minus 13 is going to be a plus 12 on this side. We'll divide everything by 2, and we're left with y squared minus 5y plus 6 is equal to 0. And then we'll factorise this down, and what we can say is, well, we need to times together to make 6, add together to make 5, so that's going to be 2 and 3. So it's y minus 2, y minus 3 equal to 0. So our values for y are going to be y is equal to 2 and 3. Again, we need to take these and we need to substitute them into either equation and find the value for x's. This equation looks a little bit simpler, the linear one, so we'll plug it into there and see what happens. So x, when y is equal to 2, is equal to 2 minus 5, which is equal to minus 3. Doing a similar thing for 3 then. X, when y is equal to 3, is equal to 3 minus 5, which is equal to minus 2. Beautiful. So our solutions then are going to be, well, y is 2, x is minus 3. And then also y is 3, x is minus 2. And they're the solutions to our equation. Again, we can check this by plugging in both values here, x, y, into this circular equation and seeing that we get 13. So plug it on the left-hand side, do we get 13 on the right-hand side? And then doing the same thing for the minus 2 and the 3. We can kind of see that straight away, because 2 squared is going to be 4, 3 squared is 9, they make 13. Same thing here, 3 squared is 9, 2 squared is 4, so we get 13 again. Beautiful. The situation where you've got like two nonlinear equations and you're trying to do it should be a very similar setup. It's basically going to be you try and eliminate one equation, you could try and eliminate one variable even, sorry, and then you're left with one equation with one unknown. Usually it's going to be in the form of a quadratic, and then you solve that quadratic to get one of the variables. Let's say here we've got the minus 3 and the minus 2 for the x, and then you use the original equations to find the other variable.